All right, looks like we're live. So, guess we'll get started then. Just working on today. I think I can work on ManGen, which is a man page generator for Zig documentation. So Zig comes with or Zig has Autodocs, which is used to generate the documentation website. So here, all this documentation is automatically generated from documentation comments in Zig. And what I'd like to do is have that similar ability or similar resource, but using man pages. I enjoy being able to look at things in the terminal using man or any other kind of man pager. And yeah, so I've got some stuff working. I've been working on this for a while on my off time. And so I've got some things I can show so far. If I look at this, we've got, yeah, all these generated ones here. Let's look at parser. If I do man, parser.zig, man, parser.zig there. See, it generated this. All this is text from the, what's the word? From the documentation comments. But you can see it's not formatted very well. In fact, there are some formatting mistakes right here. The .p, this should be something else. So if you open up parser.zig.3, yeah, should be like that. Stuff like that. And there's also lots of mistakes, being generated here. So you can tell this is a, so now let's see if we man that, you should see a bit better. Parser operates at 2 levels. Yeah. So right now, most of this code is kind of code that I've copied from Autodocs and then reworked. So if you look at the renderer is basically everything is from Autodocs, except that then I went in and instead of rendering HTML, I had it render a RAW file. But apparently not fully correctly, as we can see on some of the stuff. So we'll have to go through and look at that. There's also issues with the documentation because right now it generates 1 doc page per file. And I haven't thought about how I'd like to structure that. If we want to structure it by function, and then also, should we generate function pages? Should we generate struct pages? And I think that makes sense. That's generally how man is. So if you do like man, you do like man incurses, and you'll get a whole bunch of stuff about incurses. Get nice formatting here, and there's that. And you get the description. But then if you jump down to something like, let's see, you get links to stuff, so we can jump this link here. Is it Termios? Now Termios is a library function, whereas if we go back, this is more of a whole set of library calls. Termios is a set of functions you can include as a header. And you can see all the different functions that are within there and examples, or rather the declarations. What do you call those? Function signatures for all these different functions. You get descriptions, which is interesting. Very nice, different values. So I kind of like this way of looking at it. You get a table here. That's cool. Now, this also depends on the fact that something is well documented. But I think having a file, one file, maybe being able to be included like this and saying like, hey, what's all in that file? And then versus it being a struct, then you can take a look at the struct or the function. Yeah, you know, if we had one module, man, the Zig terminology on this, but one module should get its own documentation page. But I think also it'd be cool if each function could have its own documentation page. Something like man open, which I know is a syscall. Oh, what? Perl. And read. Yeah. Yeah, you get the read syscall here. Is there other? What's a good function? Man, stir copy. What? No manual. Man stir copy. There it is. Okay. Or this is a function, and you get the different items. Oh, we're making a man page generator for Zig's documentation. So Zig already has, I was showing it earlier, but Zig has got a, it can HTML, it can render its inline documentation to HTML files, but I'd like to take what it kind of has here, where you can take a look at things, let's say like ASCII, and instead of getting this, you get a man page, which I think would be very nice to be able to then build it, have it in your man, you know, your own little man page directory, and be able to read the documentation in the terminal rather than having to go online or switch to your browser. And I also find that the what's it called? The site's kind of slow when you read through it. I'd rather be able to search it a little faster. So that's what I'm working on. So as I was saying, I've got some code already here to generate it. A lot of this is not this, that's all mine, but a lot of this is copied from the autodoc generator. But there are things that are going to need to be different. So I've got, let's see, parser. So the parser is just straight copied because this is a markdown parser. I know I've got it in a ROF directory, but this parses down markdown into a set of types of tags and whatnot here. Yeah, you got, I think the document is actually better. It creates, yeah, the parser will create a document, and the document is really just a list of nodes, and each node has some tag. Either it's the root tag, it's a list item table. So you can build through this. This is how they set it up for Zig. And you take that, and depending on what the markdown element is, you can then render it. And so previously it was rendered as HTML. In fact, there's some things that I don't render yet, and so you can still see that the old HTML things, I've just blanked them out. I don't really want to deal with rendering images or figuring out what I want to do. The auto links right now, obviously I would want to be able to link to other man pages. I am using Vim. Thank you. You don't sound dumb at all, so don't worry about that. So yeah, things like that. Thematic break. Unfortunately, I could not find. I know it's in ROF. Why do I have two windows open? Let's do this one. So like man ROF. I know there's thematic breaks in here, but I couldn't remain thematic break. But I couldn't find it, so we'll have to figure out that as well. But yeah, that's what I'm working on. I don't know what I was about to say. Bit tired, so hopefully the stream makes sense. Move the mouse out of the way. Am I gonna make this open source? Yeah, that's the idea. If I can get it to work well enough, I'll open source it and I'll throw it up on Zigit and then But yeah, I'll open source it. But for now, it's closed. It's just on my local machine because it's not really useful right now. As I said, I have it getting to this point here, so it's actually reading through all what it does actually. Yeah, I'll show you what it does. There we go. No, there we go. Here's the main function, which is really dirty. But what it does is it goes through, you give it some path to iterate over. It'll go through every file on that path. If it's a Zig file, we'll parse it. Well, it'll read through it, parse it. Just a second, I'm make sure I got this correct. So it's parsing the file here. This log message is not quite correct. It's reading file here. So it'll read in the file, takes the source from the file, takes out the AST, and then once it's got the abstract syntax tree, it goes through and it looks only at the .comments, container comments, and throws them into the parser, and so then the parser parses it out. And so that's how it works on this kind of file level. But what would be nice is to go through, maybe we'll look at what they do in the actual Autodocs, because right now it just takes all the comments and puts it there, and there's no structure. There's nothing I can say like, here's where I want to have, the message. Here's the title. Here's this. Here's that. And so there's gonna be extra things that have to be done. Well, thank you. I do a lot of Python. I do not do a lot of Java. I did Java for one project at work, and it was not that it was painful, just that it was difficult to get through. And that was not Java's fault per se. I think that was just the project I was working on. Anyways, yeah, I'd like to have it so it's not so, like I said, okay, we'll open this back up here. It's just kind of straight text because all it is getting is the text of the documentation comments. And what it needs is to have some more structure. In fact, if you look like is it prof, and prof. What is it? Graph. Oh, I see graph, man page. Can't remember what the man page for the style for graph is, but anyways, there's a certain style, as you know, if you do like man, you can see there's the, you get the header, you got to set this, all this stuff should be things that are generated from the documentation so that we can build it and have this nice structure to it rather than yeah, you can add indents, and there's graph, which is what man pages that use only really support 3 font styles, which is italics, bold, and normal. It's called Roman, but yeah, it's italics, bold, and regular. And that's like the font stylings you have. Obviously, you can see there's things like underlines, but those are usually reserved for links. Actually, I don't know what this underline is for here. So there's different manual styles for coloring of the code. I think that depends on, you can color it. I've played around with that before. It's less done, but yeah, you can color. And that's something I might play around with too, is eventually is adding some more features beyond what man usually does. But yeah. So I think the first thing, if I Is this it? No, where's my, okay. If I start adding my to-dos here, let's see, I want to, um, let's see, um, fix, uh, generation, let's see, page generation, not be a huge wall text. And I also want to, when walking the file, create a new structure that, what's the word I'm thinking of? That kind of models how the final output should be. Oop. And we'll leave it at that for right now. So I want to work on this walking and making it better. Hi, how you doing? So if we look at here, if I go to, let's see, slash dot local Zig, and let's see, lib. If we look at the Zig library, we go to docs, you can see the actual code that was used here. And so they have this walk module. I am using this as a solo project. I guess you could say for a portfolio. I'm doing it because I like programming in Zig, and it seemed like a fun project, so I started doing that. We're working on a man page generator, so something that generate manual pages. So yeah, this is what Zig does for its auto docs. You can see it has this category system, and this is all synced with this because they use it because it's a website. It needs to be synced with some JS. So if we see JS CD docs. No. So yeah, this main JS file has all these different things, and they're using WASM and whatnot. But what I really care about is kind of seeing what they're doing here, seeing if it would be useful to mimic some of that. So here they have a file, and I think that is going to, well, let's read through it. It has the AST, which makes sense. The AST of the file, map, ident, decals. Okay, yeah. That makes sense. They have a hash map. Yeah, close. I'm not taking the HTML, but I'm taking the markdown of these comments. So you can see here, all these comments, these triple slashes, these are documentation comments. And so they'll come up in Zig, they come up different than like a standard. So if I have like just two, this is just a name comment, and this will get wiped out by the AST. But with the triple slash, it becomes a documentation comment. It actually exists inside the AST. And then we can actually reference it and take the value, like take out the text and then point it to what it does. So what they're doing here is creating a hash map of the token index to this AST node index value. And that's going to be their identifier. I'm guessing identifier declarations. They got token parents, map fields, access identifiers to the containing field access node. Map field access. Okay. Not sure what that's for, but we'll look at that later. And then node decals. These are the maps declarations to their global index. Okay, so they have a bunch of maps. AI? No, I am nothing here about AI. As far as I know. Oh, the tokens? No, they're talking about like AST tokens, abstract syntax tree tokens, and stuff like that. So I wonder, identifiers, maps field access identifiers containing field access node. This is all doing here, doc tests, map function declaration to doc tests. That's very nice. Okay. And root node, its namespace. So this is how they're being able to use this file. So this is the structure they have here. And maybe we'll just straight up just copy this one. But then we have to copy all their walking value. Oh, there's a lot in here. So if we read through what they're doing here in this function, categorize declaration, you can get a category, which is a union. Okay. So you get a kind of union of U8s, union of, yep, it's a tagged union. Struct type used only to group declarations. Okay, namespace. A container is a type. Struct union enum, some kind of opaque. Okay. Global variable, nice. Function that has not been detected is returning a type. And then, oh, they have a type function, which does return a type. Okay. A type. Specifically, it is literal type. A type is a primitive identifier that is also a type. Okay. This is starting to make sense. They're going through, they've got different categories that they want to use, which probably map to things like, we go to the standard, right? You got types, namespaces, values, functions, and struct. The struct here is source, because in Zig, every source is also a for every namespace is also a struct, which is sometimes a source of confusion, but you can see all these different namespaces they have here. They got like SIMD. Let's take a look at SIMD. You see that SIMD also starts with a struct. SIMD, and has all the basic documentation here. And then they got types, and they've got links to those documentation. They have the types plus the links. And so I think that we can do something like that if we look at, if we do like man termios, you have something similar here. You got the name of what we're looking at, so that we'll get that from the file. I think that is fine. And then everything's going to be in the third section. So in man pages, there are different sections. There's section 1, 2, 3, section 1 through 9. And each one depends on what the menu, like what you're actually looking at. And so 1 is for programs, shell commands, 2 is for system calls, and 3 are for library calls. And I think everything that we're going to look at here is going to basically be library calls. I guess we could also do some ones if we were displaying the help information for an executable. For right now, I want to focus on library documentation. And so that'll be, everything's going to be section 3. Because yeah, we're not working with any special kind of non-file files or formats, games, nope. Miscellaneous and kernel, yeah, system admin. These are all stuff that Unix should, the Linux operating system should be providing. So we don't need to worry about those. Really, we're just looking at 3. So when we look at something like man termios, we can see, hey, here's the name, and it's gonna have termios, but also gonna have a name of all the different. Here, it's got a whole bunch of different things in it. And I think what we could do is more mimic what they've got on the Zigling documentation page, and say, put all this information would go right here, basically, and then types might be down here further. Problem is that these man pages are a lot more fleshed out than the Zig documentation. And so ours aren't going to look as nice there. But I also like here where they got the synopsis, and they've got all of the function signatures, which I think is kind of nice. You got all the function signatures here as well, but it might be nice to have it like just list the function signatures. Now maybe you have to list function signatures with their documentation. Just that sometimes some functions have more documentation than others. Okay, so now that we've kind of seen what they're doing here, I want to look through this code a bit more and see how it's used. So I'm betting, let's see, walk. So in the main page, they got walk.decal. Okay, yep, walk decals items. Okay, so they got this loop. And they're looping every item in decals. Interesting. Okay, so here's comes an empty array managed. Okay. So decals is a public global variable here. Decals is global variable, and it will at some point be filled. So if we go back to where they're doing in the main, you're in WASM main, this is part of query exec fallible. At some point that walk, let's see, has to get filled in. Unpack inner, that might be it. Support function, find module root, module index. See, where's it's got to be here. Well, get or put, yeah. Because something's got to populate this walk. Okay, yeah, it's got to populate what this walk does. What these walk decals do, I guess I should say. Something populates this. Yeah, here, add decal, which is part of this index inner. So you got the file structure has this inner enum of U32 called index. This is a Zig syntax, no, not syntax, what's it called? What do you call it? Idiom, the Zig idiom. So there's not like a way to, well, this is how you can create like a unique integer type. And so you say, hey, I want to take index. Index is an enum of U32s. And then you don't declare any values. You just declare underscore, which just means every other value, right? So as an example, I will show a different example here. If I was going to do this, did enum, did my number enum, and then I wanted to have, I'm going to specify it's a U32, which is a 32-bit integer, and you can then specify like 0 to be null, something like that. And then you do that. What that just does is I take, enum of U32s means that it can take any U32-bit integer value, but we've only assigned 0 as a specific value. In fact, actually, I think I got null 0. I had that backwards. The syntax backward there, but See if it, yeah. So that's better. That's the syntax. That's correct. So you could say, hey, null is 0. Now, obviously, you wouldn't want to do that because null is actually a keyword. So maybe say like none be 0. And then everything else, this underscore just means I want to keep every other value is a valid, every other U32 value is a valid number, valid my number. But then you can use it for type safety. So when you say, hey, something takes a my number, you can't just pass in some other number. So that's what they're doing here with this index. Is they're saying they're creating a specific index type for the file. It's U32, and they don't have any. There's no named value for it. Just it's a special way to create a type for numbers. So rather than saying U32, because then I could pass any number there from any source by saying I index, I have to pass it in a value that came from something that generated an index value. Now, of course, you could always cast some U32 into that index value, but then you're explicitly doing that rather than accidentally passing in maybe an index for wrong thing to this thing. You're saying, nope, this is an index from this structure. So then you're adding decals. You're taking decals, which if we look at the references, yeah, that's the public variable. Yep. So you're adding to that a node and the file, this structure. Okay, what is this structure again? It's an array list unmanaged of decals, and decal comes from this decal file here. Okay, so here's a declaration. AST node index file. So it takes in a node. It takes in a file index, a node index, a file index, and its parent, which is also an index. Lots of indexes being used. So here you see, this is exactly what I was just showing. You have this decal has its own index type, which is U32, and you can say it has a none value. Now they picked the maximum U32 value to be none, which makes sense because 0 is probably, if you're counting from 0 on, you're probably not going to get to 4 billion items in your list, but you'll definitely start with the 0th one. So here you're saying everything else is a valid number. I want the 32-bit one to be none, or rather I can reference it with the tag none. Okay, and that get, so that's what we're doing there. So going back to where we were, reading through this, adding this declaration adds decals in here. Okay. Kind of want to see where this is used. So if we do here and add file, okay, it's adding a declaration. Where else do we add declarations? We're doing struct declarations. Okay. And again, in struct declaration, if we see a line var declaration. Okay. I like it. Okay. So I think what would be good is for us to do something similar here. To have our own walker, which would actually help would actually help with the gosh, why can't I think with all this code here? Because right now we're going through and we're basically walking it. We're doing what they're doing here for every file. But then I'm just creating, I'm not even creating a struct. I'm just feeding it straight into this parser, which then parses the markdown into something that can be generated with ROF. But I think what we really want is to generate a kind of list of declarations. And then from each declaration, this is where it's different because they had the markdown parser, and we have a markdown to ROF, or yeah, markdown to ROF renderer. And that works for some of it, but we'll have to have a meta ROF generator, which will take down our special thing, which what they have here is, if we look at this, I don't have tree installed. Oh well. Yeah, we have this main.js file. If we go to cd wasm, you can see that they've got what they have is the markdown system. Now this looks better. Let's just do it here. Yeah. So what they have is the main.js function and the index.html, which is used as the kind of the framework, the skeleton for all this. And then it gets populated using wasm. It gets populated with all the information they need. And that's not what we want to do. We want to generate a man page. And so we need, well, they have this index.html, which exists as like a structure or a skeleton. And then within there, they go through and for each declaration, use the markdown that's inside the doc comments to then generate the little splits that they need inside of it. We have to take the doc comments, take the markdown, generate it to a ROF, but then insert that ROF inside another file kind of skeleton system that we have. And so we can't do it quite like they do it because HTML is depending on the browser to do that. Unless, can you? I don't know. Can you with ROF include other files? Include the external ROF in a ROF file. Include variable ROF man page questions. Maybe I thought I saw all these are references. I can read ROF here. So let's see. Man ROF. Include. Import. Can I import into a ROF file other ROF files? Oh, I haven't found that, but that's an interesting question that maybe we can look at there. Excuse me for just a second. Oh, okay. Oh, already 5:30. Okay. Sorry, I lost my train of thought there for a second. And you guys can't hear this, but I put my music back on. Okay. So yeah, I think it'd be good. Let's start with our own file. Put in the source. We'll call it walk.zig, just like theirs. And I like what they're doing there, but let's see. Walk. They had a concept of file, and I like that. We're gonna do a construct file, and this is gonna be, man, you think that I know how to do Zig. This is gonna be, it should be public. This is gonna represent the file. Hmm. When we looked at their code, what we kind of saw here, oh, that's not the right one. So when I looked at this, what we saw is we need a way to represent our represent our raw file structure. And I think that's what we want is maybe we do that in a separate, we do fmn. We do a rof.zig. And this, we're going to reserve this as our a internal representation of rof man page. And so then what we need is you're going to do do like let's see, const age equals struct, and we want to do it something like needs a title, which is going to be some U8. It needs a man page section, which is going to be a we'll just do a U8. Should really only be 9. So let's see, 2, 4, 6, 8, 2, 2, 4, 6, 8 is U5. Man page. We'll just do section. Can have sections. Wow. From 1 through 9. Title. Every man page is to have a title. Okay, what else do we need for our man page? Maybe like here we'll want to have I really think that's probably all we need right there. Because rather than saying like, hey, every man page struct needs to have these sections, what we really want is to just give it the ability to render those functions. So we need like a fn render namespaces, and that's gonna be a void. It's a kind of errorable void, and it needs to take in some namespace criteria, probably a render. What else do we have on the documentation? types. Render render FNs, bars, maybe do globals. Let's see, what's one that's got, yeah, let's do like standard.mim. Because I know that that has some, yeah, values. That's what they call them, render values. So these are values that are kind of struct global that you can use. So like split is just a value. It's a comp time value here, not comp time. It's a okay. Yeah, it's been deprecated. So if you use it, you're gonna get an error. That makes sense. Tokenize, I'm gonna say is the same. Let's find another one that's yeah, byte size in bits, 8. And look, it says it's a constant. So that's kind of nice. I like this. You know, I just want it in the terminal. Okay. Standard library currently thoroughly depends on byte size being 8 bits. See the use of U8 throughout. Yeah. A non 8-bit byte platform. That would be interesting. And what we could do is take some cues from what they just have like a fn render function, and it could take in some kind of node, right? Kind of like they have at decals. Maybe it takes in decal type. Decal is a decals type. And I'll need to take in some writer. And it'll switch on the deck. Switch on the decal dot tag or something like that. And then it'll do stuff. Okay. Now what does it not? Oh. You think I know how to write Zig, but I don't. Okay. Get mouse out of the way. I'm liking this so far. So I'm gonna leave this here for right now. Should it cause any problems because it's not being used. But this is the idea. We're gonna take everything that we have and throw it through the page. And what it will also need is so actually we're gonna do like so this could be weird if you don't know Zig, but this is something that is not officially part of the standard, but people are trying it out. There's actually a big discussion on it. Let's see, Zig bottom imports. Yeah, you can see this here. There's a whole bunch of questions here about why people are starting to do bottom imports. In particular, Andrew K has been doing it. And so there's a whole discussion if you want to look at it. I think it was quite enlightening. I was very opposed to it at first, but decided to give it a try. And it's actually kind of nice. I've kind of enjoyed it. So what you do is you write your imports and your declarations at the bottom of the file instead of the top. And the idea being is those things are rarely the most important things to see. And so what's important about them is them being in a place that you know where they are. And so bottom of the file is just as good as the top of the file. That's kind of the argument for it. There are some other arguments about that. Tests generally have been placed at the bottom of the file. I personally think tests should be placed as close to the thing that they are testing as possible. So if they're testing the whole file, then yeah, they at the bottom of the file. But if I was going to write tests for here, you can just do test render namespaces and do some tests here for it. And I think that is better for the tests to be right by their code, because tests often just give you how it's supposed to be used. And also, if you're writing tests and working on cleaning up the code and going back and forth, rather than jumping between different sections of the file, it's better. So what we want here is import, and this is going to be, I hate that this snippet doesn't work right. Renderer. Yeah. And it's going to be import dot slash rof slash renderer.zig. And we'll probably also need the parser here as well. Okay. We'll keep that for right now. So it's giving me this error about decals not, being a something. So let's make it something. Let's make a source. Decal.zig. And so declaration. So the declaration, what they've been doing is, if you look at, they use the AST node index, which we could use. Because then as long as we're carrying around the AST, then we can look at the AST, grab the text for it. Right? Yeah, because we have to look at how they do that. But yes, declaration. I don't know if I need any documentation now, because we're going to be using this. Let's see, declaration type that. And this is going to be struct. So let's say it's got to have a AST dot node dot info. Let's see, std const AST equals standard dot zig dot AST. Okay. Dot index. We'll do that too. And it needs a type, or a tag. So we're going to give it a tag, and it's going to be tag. Tag is going to be a new thing. As you can see, it's a const tag equals enum. And it isn't, and it should be the different kinds of declarations that we're going to have in our file. So we're going to have namespace. What else do we need? We need value, struct, and what else do we want to have in here? Let's take a look at what they've got in these. Function. What else? Type. Actually, I don't think I have to think type I can use. Just in case, yeah. Anything else in the types that we, can take from there? Just make this public. And yeah, so then where were we at? We were in the, oh yeah, we were rough. Just rough.zig, rough.zig, yep. We're gonna get rid of that. We don't need that right now. The bottom, we don't need you right now either. Okay. Const decal equals import decal.zig. I gotta fix my keyboard here. It's making noises I don't like. There we go. Okay. Oh, there we go. Yeah, writer's not. Fix all. Okay. Okay. So here we're going through the AST. We're grabbing .comments, container .comments, but we don't actually want to do that. What we want to do is go through the AST and find all the declarations we're interested in and map them to their documentation comment. And let's see how we can do that. I'm going to actually look at I want to see how they do it here. They got a bunch of categories. Oh, function is a primitive error set. Ooh, error set. That's something you probably want to do. Global constant aliases. Yep. Should just take these. I don't know why there's a difference between a type function and a function that's not been detected as return. Oh, that's right. We'd want to have that because type functions return a type rather than a value. So does the documentation look different there? What's a good one? Standard.heap. Let's go there. Heap types. Debug allocator. General purpose allocator. All right, debug allocator. Interesting. Yeah, see, it's a type function. Okay. So I thought debug allocator is a function, but it's a function that returns a type. So it's okay. Oops. We're just gonna steal this. Steal all these. Think. Yank that. And where we had decals here, we're just gonna paste that here. Now we just gotta go through. We're gonna do some vim boo here. Let's see. I guess we just do. Norm F D. Oh, but I want to add in a space. norm a. What? Norm a. There we go. Just clean it up there. Okay. All right, so here's all our different name tags. We got namespace, container, struct, union, enum. Oh, okay. Global variables, functions, aliases. Awesome. This is going to be good. So then, where was I? Oh, I was looking at how they take this file, and what they're doing is they need a map. What they need to map is see the token index. Okay, let's take a look at that. Token index versus versus the node index. So it finds out where that token starts in the AST. Okay. A bunch of maps here. Okay, categorize it. So here they got the AST, the file index get AST. Get AST, which then takes its index, returns a pointer to the AST, which is I file.index dot get. Okay. Boom, and then returns the AST. So here we get takes the values, files, those files. Oh, and this is how they're being able to create the links, I think. In fact, I think that's what it says up here. Find and annotate identifiers with links to their declarations. Okay. I wonder if we just, okay, maybe we just copy this all. Because really what we need is to take the output of this and use it with the ROF thing that I was working on earlier. And now I think I'm starting to understand it. I don't see why I'd want to rewrite all of this. They've already got it here. Node tags. Items. Node list. Multi-array list. Slice. Contain items. Oh, yep, those items. Get the items. The comp time field, just the tags. We go back to nodes. Node list. A node. What's a node? Node has a tag, main token, and data. Okay. So then what we've got here is getting the tags from the nodes, and it's taking the token tags Okay, and node tags is going to be, if we look at this, I mean, it's going to tell you it doesn't know. It's an array of some unknown type. That type is a tag. We look at the tags on the node. The tags are all these: root, using namespace, test decal, global var declaration, all these things. Okay. Look at all these different tags that you can have on the AST. And basically, it's going to go through it. It's going to get the node, which we get from here. It's going to switch on it. And it says, hey, if it's a root, then we've got a ast.rootDecals member. Okay. Interesting. Space node. And then you got global. So what it's doing is switching over it. It's going to root if everything's a global variable, local variable declaration, or simple variable declaration, or line variable declaration. It becomes a global. What are we getting out of here? A category, which is what that thing we copied up here. It's a different categories. So it's just returning those categories. Functions are all going to be this, and that's it. You know, it doesn't really interesting. Excuse me. Oh, it returns categorized function. Okay. And I skipped this whole thing here about expressions. Did I? Oh, no. Okay, it's a checks if it's a thing and makes it key. Otherwise, it just categorize. So let's look at expression. File indexed get. Okay, so it gets the file. It gets the index of the AST. Takes a look at AST's nodes. We got the tags. We get the data. Get the main token and the tag from the tokens. Where tokens come from? Oh, it's part of the AST. Okay. Which is a token list. Okay. Very cool. This comment looks a little out of place. I'm just gonna say right here. I think this is like, I'd be curious if I read through the history if this is a comment that got left in, but maybe not. Okay, it's debug. Let's see. So then it's gonna say if it's looking at the tags, no tags. Interesting. And it's categorizing a lot of data here. Oh, look, here's a add file. Parses a file and returns its AST. File cannot be parsed, returns the AST with empty file. Yep. So this is where I think this is what we're curious in is. Takes a source, seen that. Token offset, AST tokens, items, render. Scope. Okay. I got a little sidetracked here. I apologize. How? What I really want to know is how we link these back to their yeah, to their, what's it called? Doc comments. Okay. So they do it in decal. It's got to be here. Find first doc comment. Yep. So you take you got the AST, you get the token index. And then while the IT is greater than 0, if, yes, you take the iterator, which is token index. While the index is greater than 0, you subtract the index. Yes, you're going to backwards iterate. And you say, hey, is it a comment? The dot comment, you're not backwards iterating. You look before the token that you're at. Am I reading that right? Iterator is greater than 0. Oh, only, duh. Yeah, so you're going to backwards. I'm stupid. Okay, so yeah, you backwards iterate. You're going back 1. If it's not a dot comment, if it is a dot comment, so this is where it's throwing me off. If the token tag that you look at right before is not a dot comment, then you return iterator plus 1. Otherwise, you go back again. So otherwise, if it's a dot comment, you keep going back, and you keep going back, and keep going back, and going back, keep going back, keep going back, until you get to the first not dot comment, then you go back towards it. So this has got to be called when you know that you are already looking at a dot, like something's got to have a dot comment right before it, right? Yeah, var decal dot first token. So you go to the variable declarations, first token, and you find the first dot comment. And that's where it's used. Okay, that makes sense. Makes a lot of sense. So they're using here is not quite what we're going to use this for. Okay. So that's how they find it, is they go through each, they get decal. Interesting. And they start going through. Wait. Extra info. That's how they get the dot comments. Let's see, where else do we find it? Doc comment. We see it there. Find first dot comment. Interesting. So this is where they're building out the HTML for a different thing. Okay. Very cool. Very cool. So I think then what we'd like to do is, if we know in the index, so let's go back to node here, because this might not be what we actually want. Token, look at the main token, which gives us the index of the main token. And then what we want to do is find the previous, what's the word I'm thinking of? Oh. Excuse me, sorry for yawning. What we want to find is the first token, yeah, dot comment once we get a AST node. We'll see. We'll play around with this a bit. Let's go back to then our main file here. And just realized that. Let's see. That better. It might be better to zoom in for you. Oh yeah, what we're gonna do is we're gonna go through. Right now, what we're doing is going through and walking through and doing that. And what we're saying is maybe we want to walk through ourselves and categorize everything, or just copy the walker, get their decal. Yeah, copy walk and decal. Only problem with decal is it has a whole bunch of. We might have to rewrite our own decal, or just copy it and rewrite what we need, because we don't need all the HTML stuff. If I look at decal, there's like HTML. Is there? I thought there was HTML. Oh, then yeah, maybe this is fine. Because then we take out this decal stuff and then get, where's decal used? Outside of it. Interesting. Sorry, I had to sneeze. Hopefully you didn't have to hear me sneeze. I don't know. I think that this is worth writing our own, even though it looks pretty complex. I think having our own walker will work better. So let's do our own walk.zig. Oh, I already have one. That's right. I'm such an idiot. That's right, because the walk is what we were saying was going to generate a file. Has it? Maybe I already wrote one. I didn't realize it. Because yeah, we have decal.zig. We've got rof. So rof is, yes, that's right. Rof is going to get a page. Page is what is being rendered to the man page. And what we want to render is some declaration. And so then what we want on the files is every file we're going to go through and gather all the declarations. So decal should be a tag AST. Yes, yes. So we want to do at import decal. Okay. Pub console bar. Let's see, we call them files equals we do standard array list unmanaged of file. This would be a list of all the files that we've got. And the file should just have a I mean, we could do this. Const index enum e32 and so that will identify. So the one is a where we are in there. Oh, what else do we need in the file? Probably a list of the not yeah, we wanna have a like a list of all the declarations in there. Yeah, list of all the declarations associated with that file. So we want to do like standard dot array list unmanaged decal and should be empty at first. Okay. Yeah, we'll do is none. Standard dot int math dot I32 is it x int I32 or U32. The reason why we do that is that when we create this, we might not have an index for it. We only get the index when we put it in. Maybe. We might not even need this. We're going to get rid of that right now. If we need it, we'll come back. Okay, so as it's kind of a bunch of declarations. So what we need to do is figure out how we want to how we create these declarations. And that's what the walk does here. So we say, they call it parse. So what this is going to return as a file. My allergies is getting to me. Parse a file into its. Oh, we also want to save. Do we want to save? Parse file into its AST kind of types. Declarations. That's what we want to do. So it will take in is a standard .fs file. As a return a file of our own. Actually, we're gonna take what we have here. A lot of this code here is about, how to iterate a file. Let's copy this. We're going to get the source. Sure, the source file. Yeah, this is all copy here. We're going to do that. We're going to parse the AST. And this is where we get to here. Where's my walk? Okay, there it is. It's mad that I don't have log, so const log equals standard dot log dot scoped, and it's walk. There we go. Source. Oh, we need an allocator. Right, we do. Const allocator. Const allocator equals standard dot mim dot allocator. Okay, max bytes. So, yeah, to read the whole file in. And then adjust the source. So this is because the way, what's the word I'm thinking of? The AST parser works is it has to be, you look at AST parse. Oh, I've got to import AST. I have AST. I thought I already had it here. Const AST equals, move you down. Equals standard.zig.ast. So you look at that, it takes the allocator, takes the source, and it has to, the source has to be null terminated for the AST to work. And so what we do here is a little trick where we say source file has to end in a new line. And if it doesn't, then what we do is we just give it an empty file. That way the whole thing doesn't break. But if it is an empty line, right? So if the file is empty, we create empty line. If the file doesn't end with a new line, we don't parse the AST. We throw a little error. Or rather, we log an error about that. Cannot parse AST. And so, with that little, because of that, because we require that it ends in a new line, we could take that new line and actually change it to the null byte and then pass that in. So that's like an adjusted source. And that is a valid, what's the word I'm thinking of? Thing to do, because that's what they do in Autodoc. So if it's good enough for Autodoc, it's good enough for us. That's how we're going to do it. So then we did the AST parser, and we dinit that. Obviously, see, yep, parse that. And now that we have the AST, what we want to do is walk through the AST and start categorizing the decals and finding, like, find and categorize decals. So maybe like a new function. Yeah. Then categorize, let's see. Because remember, a decal, you just need the AST node index and the tag. Okay, let's look at the, see if there's documentation on, if we go to standard Zig AST. Zig syntax, the root node is at node 0 and contains a list of subnodes. For Zon syntax, root node reference to externally owned data. Okay. Reference to, yep. Source is just the source code that we just passed it in. And then node list slice. Root node is assumed to be index 0 since there can be no reference to the root node. This means 0 is indicated to be null. I mean, I guess that is there, yeah. Okay. Wow, we've got a lot of good functions here, but the question is, my question is, what is the difference between the nodes and the tokens? Because token has, token index. I look at the token type. Zig's tokenizer. Okay, so just all the tokens that are in there. Whereas the node is got its own tags. Foo, comma, foo, semicolon variants exist to ease implementation of AST last token. Interesting. It's an enum. Okay, I'm gonna look at this in the code because this is one thing the documentation doesn't allow. We're gonna go to node. So the nodes have their own tag type. That is a root. Using namespace, right hand side unused, main token is using namespace. Okay. Then we have test decal. Left hand side is test name token. So, okay, I might be missing something here because I guess LHS, RHS. Everything is assumed to have an LHS, RHS. Let's scroll all the way down. Holy cow, there's a lot of tokens. Don't care about. Main token. That's okay. So it's nice that it tells you what the main token of these things are. Oh, data. I bet that's what that's. Yeah, okay, yeah. Data is the left-hand side, right-hand side. And the index is a node. What's the index? Okay. Where's token index? Tokens. Token list, we have token tag, and here we have all the tokens in the tokenizer. Okay, here we have keywords, tag. All the possible tags we can have in Zig, keywords. Not a lot. Interesting. Invalid period asterisk. Identifier, string literal. Okay. All right. Well, I've got to wrap up for today. So, but it's been really helpful actually just walking through this and taking a look at, oh, look, there's dot comment and container dot comment. Those are two important ones for us. And then I think what are going to be important are these identifiers is really what we're looking for. Because I don't think, yeah, I think there's anything else. Okay, I've got to call it for today, but thanks for watching. Thanks for chatting if you chatted. Thanks for watching if you watched. If you got this far, you probably watched. I'll see you later. Happy coding.